8.3, we will learn about division properties. In 8.1, you learned about multiplying, and when you were multiplying, you were adding the exponents. So it makes sense that when you are going to divide powers with the same base, you will subtract exponents. So in this example of 4 to the 5th over 4 to the 3rd, you'll see that the top has 5 factors of 4, and the bottom, or the divisor, is 3 factors of 4. So when you look at that, you would say there's 4 to the 5th minus 3, which gives you 4 squared. Or if we were to simplify, if you want to see it simplified here, we would say that 4 divided by 4 is 1, 4 divided by 4 is 1, 4 divided by 4 is 1, leaving us with those two factors. It is a simple trick to go to the factor that has the larger of the two exponents, and then use what you learned in 8.2 and change that other factor to be a negative. That is where the subtraction component comes into it. So if we look at a few more of these, we have 6 to the 5th over 6 to the 4th. So we will go ahead and I will look at the larger one. So I'm going to say 6 to the 5th minus 4, which would give us 6 to the 1st, or just plain 6. In the next one, do not let the negative by the factor throw you off. So we have the same base, negative 5. I'm going to go ahead, they're equal, so I will move it up to the top. So negative 5 squared, or to the second, minus to the second, is going to give me 0, and 5 to the 0 power. Remember, anything to the 0 power is 1. Letter C, we have a couple operations going on together. In our numerator, we have the same base, 9 to the 4th and 9 squared, so we will combine them using our addition. And then the denominator is 9 to the 7th. This time, 9 to the 7th is in the denominator. So if you went and you took it to the numerator, it would be 9 to the 6th minus 9 to the 7th, which would give you 9 to the negative 1. Then you would want it to have all positive exponents, so we would change it to the reciprocal, which would be 1/9. Now, a trick that I learned a long time ago, as I mentioned before, go to the one that has the largest exponent and then move the smaller one. So in doing that, I would leave nothing up on top, so I'll go ahead and give it a 1, and I would then, as my denominator, I would have 9 to the 7th minus 9 to the 6th, and I would come out with the same thing, 1/9. Now, the only time that gets tricky is be careful when you're using negatives. Again, the greater number, so picture your number line, the greater number is the one that you want to move those factors to. And now finally on letter D's example, we have some variables. So first we have some multiplication going on. When we multiply fractions, we think of the whole number is just over 1, and then we can go ahead and we can multiply going across. You could also do some simplifying as we do when we're multiplying fractions, and it would be the same operation we're going to do here just in a minute. So they went ahead and multiplied across, giving you y to the third, or y cubed, over y to the fifth. The next step then is they're going to move the y to the fifth up to the numerator. So we have y to the third minus 5, which would give you y to the negative 2. And then that would give you that reciprocal 1 over y squared. Again, let's go ahead and put in here some of the things that we know from fractions and what we have learned about our division rules. So we have a common term here, so let's go ahead and simplify it. The 5 is the larger one, so y cubed, that would be y times y times y. And I have that in here, y cubed, I would take y cubed out of here, and I would end up with y squared, which is what we end up with here. The denominator is y squared, and the numerator is 1. Moving on, we're going to do some that we're going to have some other properties involved. So using the power of a quotient property, we're going to simplify these expressions. So the expression is going to be 2/3 squared. So it says square the numerator and the denominator and then simplify. So 2 squared would be 4, 3 squared would be 9, 4/9, and that's actually in its simplest form. Now we're going to throw in a variable, so rewrite the fraction. So we're going to take each part of that fraction and cube it. So our first step would be -3 cubed and y cubed. Applying the power of the quotient, we write that as separate terms. And then we're going to go ahead and simplify. And when we simplify, we can go ahead and multiply out our -3 cubed. It's an odd numbered exponent, so it's going to stay negative. So we have -27 over y cubed. The y cubed we cannot simplify any further because we do not have a value for y. Moving ahead, we have 7/4 to the -3. So we're going to use our power of a quotient rule. We're going to expand that. That would be 7 to the -3 and 4 to the -3. If we then use our definition of negative exponents, we're going to put those negative terms as their reciprocal. So the denominator 4 to the -3 will change to the numerator 4 cubed. And the numerator 7 to the -3 would change to its reciprocal 1 over 7 cubed. And so here is our new term that we need to simplify. Notice that we got rid of the negative exponents first. And the next step says we need to simplify. So when we simplify, we're just going to multiply that out because we have terms that are values that we can expand using the exponents. So 64 over 343. I'm going to pause in case we need to, oh no, I don't need to put these in two separate ones anymore. Okay, so look at this expression. We have 2x squared y over 3x, and we have 9xy squared over y to the 4th. First, we're going to go ahead and we're going to multiply the fractions. So, when we're going to multiply the fractions, we're going to expand that out. We can multiply the like terms. So this first step here, I'm multiplying my 2 and my 9, giving me 18. I'm going to combine my x squared with my single x term, giving me x cubed. And I'm going to combine my y in the numerator with my y squared, giving me the y cubed. I'll do the same thing in the bottom terms. 3 is my only coefficient, so that 3 times 1 is 3. I only have one variable x, so that stays the same, and one variable y, and that's to the 4th. Now I can apply my division for the powers, and I would go through each term separately. And I am writing with my finger if you can't tell. So I'm going to take my terms apart a little bit here. 18 divided by 3, I can simplify that to be 6. X cubed, let's see if I can get this without chopping too much off. X cubed divided by x, so 3 minus the implied 1 here for this exponent. 3 minus 1 would be x squared. And then we'll put everything up to the numerator. So y to the 4th is going to come up here, so we would have 3 minus 4, and that is what gave me my -1. So to finish that off, because we do not want any negative exponents, the 6x squared terms are all positive exponents. They can stay as the numerator, but the y to the -1 needs to go to the denominator, and that's y to the 1st, or that's an implied 1 there. Now again, using the way that I had said that I had used earlier, if I have my 18 and x cubed and y cubed, I'd have to look at the printed one as well. My finger is not always the most legible. And then we have our 3x. Remember, I put it into the first, and y to the fourth. Now I'm going to apply the rules of negative exponents right when I am simplifying. So again, go to my coefficients, 18 over 3. That still gives us our 6. We're okay there. We have 6 cubed in the numerator, and we have x cubed in the numerator and x in the denominator. So I'm going to do the larger is x cubed, so x to the third minus 1 will give me my x squared. Sorry, that's not very good at all. And then my y terms, I have y to the fourth in the denominator and y cubed in the numerator. Y to the fourth is the larger one, so I'm going to bring the cubed down here to subtract it. We're in division, so I'm subtracting. So 4 minus 3 is going to just give me 1 as my exponent. So it gives me that same answer. You can choose to do it either way. Now simplifying another one, this time we're going to raise it to a power. So we're going to do the power of a quotient first of all. Both the numerator and the denominator are being raised to the fourth power. So we have 2x to the fourth and y squared to the fourth. Now we need to use our product rules from the first lesson. So because it was raised to a power, that exponent outside of the parentheses is applied to each term. So we have 2 to the fourth times x to the fourth, and we have y squared and then raised to the fourth. So when I go to simplify that, I end up with, I'm going to multiply my 2 to the fourth out, I get my 16, x to the fourth, and then in the denominator, I have 2 times 4 since it was raised to that power, and I have y to the 8th for the final one there. I don't have any like terms, so I can't do any more simplifying. Now, using our new property in real life models, we can go ahead and we can look at the stock exchange. So the number of shares, and they're going to use the uppercase N to stand for in billions, listed on the New York Stock Exchange from 1977 through 1997 can be modeled by, so that exchange N equals 92.56. And it's going to be times 1.112 to the T power. Now, T equals 0 because that represents 1990. So we need to find the ratio of shares listed in 97 to the shares that were listed in 1977. To do this, we're going to use T. It's going to be a negative 13 for 1977, and T is going to be 7 for the 1997. Now, where did they get those terms? That's how many years there is a difference between that and 1990. Because when we were reading our information, we found out that 0 is going to be at 1990. So 13 years earlier was 1977, and 7 years later will be 1997. So that's the positive, and the prior would be the negative. So the number listed in 1997 was 92.56. We're going to multiply that by the 1.112 because we were given that as our formula, and then we're going to put in our exponent 7. That's for the 1997. We're going to use that same formula, but we're going to put in the exponent a negative 13 because remember that 1977 was 13 years prior to that. Now we're going to apply our rules of exponents, and again they went to the numerator, so they're going to find the difference because we're dividing, and so we're going to do 7 minus a negative 13. Also, if you apply my rule, 7 is the larger number between these exponents because this is a negative 13. So when we subtract there, that becomes add the opposite. We have 1.12 to the 20th power. And using a calculator for this, you would find out that's approximately 8.4. I believe we have one more example, possibly two. Example 5 is going to start to teach you about probability. So we just came from the stock exchange, and now we're going to do a little bit with probability. So you toss a fair coin 10 times. Show that the probability that the coin lands heads up each time is about 0.001. I believe we were tossing coins in class. So probability that the first toss is heads. Well, if we're using a fair coin, there are two sides to every coin, and one side's heads, one side's tails. So we have a 50-50 shot, or 1/2, 1 out of 2. Okay? Probability that the first two tosses are heads. Now, we're going to use our probability 1/2, but we're going to square that because we're doing the first two tosses are heads. You'll see a pattern. The first 3 tosses would turn into the cubed, or the exponent 3, and so on and so on. So the original question said if we did it 10 times. So the 1/2 times 9 would be the 9 times, and the 1/2 times, I'm sorry, not times 9, raised to the 9th power, and 1/2 with the exponent 10 for the 10 tosses. So when we do that, we would have 1/2 to the 10th. So we're going to use that for both of our terms. 1 to the 10th is going to still stay 1. 2 to the 10th is going to expand to 1,024. Now, if we divide 1 by 1,024, you're going to get the approximate value of 0.001. So the probability is about 0.001, okay, and that's 1,000th, 1,000th, 10th, 100th, 1,000th. And I believe that will finish up our lesson. We're on our last slide. Oops.